So welcome to the first class of embedded sensing, actuation, and interfacing system. So from the name itself, we can have some sort of ideas that this particular course will mostly deal with the different type of sensing mechanism, actuation mechanism, along with the interfacing schemes for different sensors or actuators with our embedded controller, right? To develop the complete embedded system or the embedded control system. So in these courses, initially we will start with the basic background of embedded system by and showing their important applications. Then we will move forward to deal with the basic principle characteristics of important sensors, actuators, which are widely used to develop the complete embedded system, along with the different important basic interfacing scheme as well as advanced interfacing scheme to integrate the sensors, actuators with our embedded controller to develop the complete system in various real life applications, right? So having said that, let us have a look on the content and syllabus for the courses which we are going to study throughout this semester. And I hope you may have seen this in the ERP as well. So we will start with the basic background, starting with the overview of the embedded system, its architecture. And since our main aspects or focus will be with respect to the sensing, actuation, and interfacing scheme, so we will give a glimpse of important of advanced sensors, actuators, and interfacing circuits, along with the applications. Followed by that, in the next module, we will deal with the various type of sensors, actuators, their descriptions, salient features, which will be very much important to choose or decide that for a particular intended application, what type of sensors I need to choose, right? So under which we will discuss about the thermal type sensor actuator, electrical type, magnetic type, mechanical, optical, followed by that chemical as well as magnetoresistive, whereas we will deal with some of the other type of actuators also like hydraulic and pneumatic. After that, the basic interfacing scheme like signal conditioning circuit, op-amp based circuit implementation, followed by ADC, DAC, along with the environmental effects, then driver circuits, followed by some of the important signal processing aspects will be discussed as well. So this in these three modules, there these will be basically it will deal with the basic concepts which will be required to move on further. So you can consider this past three modules as the prerequisite. And in our last semester courses, some of the concepts from these three modules have been discussed in a very brief way in a single module. But here we will be dealing with the more advanced way. So initially, some portions you may feel little overlap for the basics, and after that we will move forward to the advanced topics as well. So after completing the basic ideas in this first three modules, we will move forward to the advanced techniques for direct interfacing of the sensors with our microcontroller. So you may have some ideas that suppose the sensor, what it generally does, it senses some physical quantity, right? And you may be aware that most of the sensors, we prefer that the output of the sensor should be in electrical form so that it can be compatible with my microcontroller to develop the complete embedded system. So the sensors can be of various type. It can be resistive type, capacitive type, magnetic type, and so on. So what is the meaning of resistive type? That means suppose I have a sensor and I want to use the sensor to detect some physical quantity like temperature, pressure, etc. So the physical quantity or input or the stimulus will be some physical quantity like temperature, pressure, flow, etc. But the output will be in terms of resistance change. So that is the electrical quantity, right? Whereas similarly, for capacitive sensors, the input can be any physical input, any physical quantity, but output will be in terms of capacitance change. And similarly, we can have magnetic or inductive sensors as well, because you know that in electrical domain, resistor, capacitor, and inductor. So these are the main three elements, right? So in the fourth module, we will deal with the resistive sensors, and we will discuss what are the different advanced interfacing techniques are there in order to connect the resistive type sensors with our embedded controller. So earlier, we may have some idea that if I want to connect a sensor to the microcontroller, then directly I may not be able to connect, is not it? Because the sensors will be used to detect, to measure some physical quantity, and accordingly some of the electrical property of the sensors will change, resistor, capacitor like this, and then I need some signal conditioning circuit to convert that resistance or capacitance into voltage. Then I may require some ADC or some amplifier or some other signal conditioning block in order to make the sensor output compatible with our embedded controller, right? But in this module, we will learn that even the resistive sensors can be directly interfaced with the microcontroller as well, right? So that is relatively advanced techniques, where without any dedicated signal conditioning circuit, also using the inbuilt components of the embedded controller itself, we will be able to interface the resistive sensor directly with our embedded controller. And for that, what are the related concepts and the related ideas, so that we will be dealing with in this module. Similarly, for capacitive sensors also, we will talk about the advanced interfacing scheme in fifth module. Now, you can understand that nowadays this automation term is very popular, right? Everywhere in industry, everywhere you can find the term automation, that automated thing is there. So where that human intervention is hardly required, right? So in case of and you can see that this embedded system is very widely used for different automated system or environment as well. And you all are aware about our smartphone, right? Where in the smartphone, the size, you know that it will be mostly 5-inch, 6-inch screen, and inside that small smartphone itself, you know that how many components or sensors, actuators, circuit components are inbuilt inside the smartphone. So you can understand that in order to accommodate multiple number of components or sensors or IC in a small board, how much the size of the individual components should be, right? So that's why the sensors or actuators, what we have discussed, what we will be discussing so far, along with their interfacing circuits, then we will deal with the miniaturized concept, that in order to accommodate multiple number of resistor, capacitor, sensors, actuators, or components inside a small board like smartphone, how much the miniaturization technology is required. So in that context, we will deal with the requirement of miniaturizations, the different technology or fabrication used to develop different sensor and actuator. So what we call as the micro machining technology, right? So their working principles, the IC or integrated circuit compatibility process, system on chip integration, sensor fusion, followed by their application. Then in the seventh module, what we will discuss, that so far, in order to make the sensor, actuator, or the circuit work, we need some dedicated power supply like battery, right? But that power supply, you know, this conventional energy sources like our coal, petroleum. So those are conventional sources which are having limited lifetime. Even, you know, this battery which we used to power up our different sensor or electronic circuits, so they are also having limited lifetime, and in regular interval we need to replace the battery. So in some application, like some inside some tunnel, lot of sensors might be installed, right? Then in some narrow region, or where the human intervention is very difficult, in different wireless sensor network, you cannot always go in a particular position and change or replace the battery in regular interval. So in order to meet the power requirement of the sensors or the circuits, we need some dedicated energy harvester. So the energy harvesters will be some sort of alternative or substitute of the conventional battery source, so that using the energy harvesting concept, energy harvesting technology itself, we should be able to develop the self-powered sensor network. Right? So that's why in the 7th module we will deal with the energy harvesting concepts, which will be equivalent to replacement of battery, and to design or develop the energy harvesters, what are the important transduction mechanism are there, what are their related interfacing circuits required. So those aspects we will be discussing in the 7th module. After that, suppose if I talk about the wireless sensor network. So there, and you might be hearing about the recent terminology cyber physical system. So in cyber physical system or the sensor network, that the security aspect is very important, right? So suppose if I want to transfer the sensor data from one place to another place, so then you know that encryptions is required. So different security protocol is required, to transfer the data. Otherwise, there will be possibility of hacking or losing of data, right? So that's why we will discuss the security aspect of the sensor system as well. After that, we will concentrate on different emerging applications, like we can discuss about the automotive sectors, what are the important sensors, actuators, and the interfacing circuits used in automotive domain. Similarly, in biomedical domain, what are the important that components required, along with the different case studies. And then we will also talk about the that electronic nose, electronic tongue in industrial applications, how different type of sensors, actuators, and the circuits are used. Followed by that, we will talk about the virtual sensing scheme as well, and we will give different type of tutorials, assignments as well on the related concepts. So these are more of that mostly this is the flow of the this particular courses, and we will follow this particular flow throughout the semester, right? So quickly that summarizing, so we will deal with the basic background of the that embedded system, sensors, actuators, and the interfacing circuit. Then we will discuss about the advanced techniques for interfacing circuits, and after that we will deal with the miniaturized or the miniaturization technology, how to fabricate or develop these type of sensors, actuators. Followed by that, how to meet up the power requirement of these sensors, actuators, the security aspects of the devices, as well as some important emerging applications like automotive, biomedical, in electronic nose, electronic tongue. Followed by that, the virtual sensing concepts as well, right? So I hope the flow is clear to everyone. Yeah. So before introducing this course content, so let us that discuss a little different orientation. So actually, so this semester also we have to follow the online system itself. We, although we expected to do it in hybrid mode, but because of the situations, we are doing it in online mode as well. So although there is some it seems some that difference or deviations between the offline face-to-face interactive classes and online courses, but still, depending on the situation, we will try our best to make this online platform as close as possible to the offline interactive session, right? So obviously for that we need cooperations from you as well. So both from our side as well as your side, we have to be active and we have to try our best to make use of this online platform and make it as close as possible similar to offline interactive session. So at any point of time, if any of you face any difficulties, please feel free to ask me. Please stop me and try to clarify the concepts then and there. Okay. So don't hesitate to ask questions. Okay, because often it is said that questions can be never wrong, answers may be wrong, right? So anyway, so please feel free to ask questions wherever you feel any doubts or any confusion. So having said that, let us give the background of these courses. So I hope that the embedded system, this terminology, more or less all of you have heard, and some of you have all attended the related courses as well. So quickly to brush up the that embedded systems, their applications and the formal definitions, let us proceed further. So we all have seen the different electronic gadgets in our day-to-day life, right? The smartphone, that is the that most available and most close embedded system near our hand, right? Then we can have digital watch, PDA, that street light. Then we can have different biomedical equipment like CT scan. We have robots, digital camera, phones, automobiles, this Xerox machine. We have the washing machine, ATM, this electronic voting machines everywhere, right? So we cannot imagine our today's world without embedded system, right? So wherever you will look at, you can find the applications of the embedded system, right? So embedded system, what is basically? So it is a smart system which includes the hardware as well as the software, and they will be integrated in a proper manner and proper way to serve a dedicated function, right? So formally, if we want to define the embedded system, we can define as follows: that embedded system is typically a special purpose integration of computer hardware and software which is designed to perform a dedicated function. So it is not like a general purpose computer, it is customized or it is dedicatedly designed to perform a specific function. And it is usually having the real-time computing constraints, right? So real time, what does it mean? So the timing is very, very important, right? So it is not like that offline we are doing some simulation, and in our MATLAB simulation it is showing 2 minutes, and in the practical when we will be dealing with, then it should show 1 minute. So there should not be any deviation. So it is the real time matters a lot, right? So you know that suppose this that pacemaker, which is artificial heart, right? So the pacemaker, you can also pacemaker also you can consider a very beautiful example where that suppose the way the patients who are having the heart issues and they need the pacemaker support. So there what happens, the patients usually whose cardiac rhythm is having some difficulty, right? So there the pacemaker is used to support the cardiac system. So there in that certain electric stimulus is used that externally in the pacemaker, so that the cardiac rhythm can be maintained properly, right? So you know the cardiac rhythm is having certain frequencies and certain time period. So that must be that criteria in terms of time or pulse duration, so that which will be provided by the pacemaker, that must match with the cardiac rhythm or the requirement. Otherwise the whole purpose will be in vain, is not it? So that's why the real time is very, very important. So this is the basic background of the embedded system. Now, if we want to that go inside the embedded system, and if we want to see that what are the essential components of the embedded system, then definitely we can find the microprocessor or microcontroller can be said as the heart of the embedded system. And then whatever the embedded systems example we have shown in the previous slide. So in all of the systems, the microcontroller or the microprocessor, that is mandatory, which is the heart of the system. Along with that, we need some memory for storage purpose, which can include ROM, RAM, disk drive, etc. Followed by that, we require some dedicated input output devices or the interfacing blocks, which includes sensors, actuators, along with their interfacing blocks, displays, etc. And also we need software for programming purpose. So whatever embedded system example we take, they all of them mostly will include these essential components, right? So obviously you can understand. So in this course, our main intention is with respect to the embedded sensing, actuation, and interfacing. So that's why we will mostly focus on the third block or the third component, right? And where we can find the applications of the embedded system. So uh, we can that we cannot think of any applications without embedded system. If we look at for automotive system, inside a car or inside an automobile, you know, there are lot of individual embedded system implanted inside the automotive or the car, like this. Okay. Then we can have consumer electronics like smartphone, different gadgets, in aerospace, in information technology, robotics, biomedical, then chemical analysis, as well as environmental and bio. Everywhere we can find enormous use of our embedded systems, which essentially deal with or includes the microcontroller or the microprocessor, the memory devices, then input output interfacing blocks like various sensors, actuators, interfacing circuits, along with the software programming, display, etc. Fine. Here we are showing some of the important or popular sensors, actuators. Like this is one digital micromirror whose applications you can find in projector. So this that often the projector is used to teach in the class or in seminar. So in the projector, digital micromirror devices are used. Then we can have the accelerometer, then the gas sensors, the gyroscope, pressure sensor. So these are some of the important sensors, and these are some of the actuators like motors. These are the electrical actuators. This is the pneumatic actuators, and so on. So just to give you show you the image. And here, can someone quickly tell me that why this fly is suddenly coming into the picture? Any ideas why it is shown here? Hello? Can you hear me?
Yes, sir.
Okay. So while discussing about these sensors, actuators, why we are showing the fly over here? Or here you can see some ant, right? So this is actually to show the size. You remember that in the that contents we discussed that that one module is dedicated for the miniaturized sensors. So, and we told
Yes,
that
sir.
suppose in a small board, if we want to integrate multiple number of sensors, actuator circuits, then how much the size should be. So to show that, you can see that this is the overall length of this fly, and here you can see this on top of this some rectangular block. Can you see? So that is the IC or the sensor. Similarly, here you can see the size of this ant, and here you can see the size of the device, that is the sensor, right? One example of one gas sensor. So this is to give you the idea that how small the size of the sensors or the devices is. And you can understand how much challenging it will be to develop or to design this type of small sensors, right? So you in your UG that curriculum, you may have some workshop, mechanical workshop, where you have dealt with the maybe that lathe machine, shaping machine, those drilling machine, those type of things. So there mostly we deal with the conventional machining, and we deal with the bulky structure, right? So obviously that type of machining technology can never be used to develop this type of sophisticated or miniaturized devices. So that requires the dedicated fab lab or fabrication lab, where it requires lot of that precision equipment as well as the environment. Because you can see the if this is the size of the sensor, then even if a dust particle come into the picture and fall on the device, your that devices may that performance may be hampered, right? So obviously to deal with that, we need to have dedicated encapsulation, dedicated package, those things, right? So that's why that after going through the basic concepts of the sensor, actuator, working principle, and the circuits, we will deal with the that miniaturization technology as well, that what are the fabrication technology using which we can develop or fabricate these type of very small sensors actuators in our that day-to-day life applications, so that they can be multiple numbers can be accommodated in the small board. Okay, so having said that, let us have some example illustrations for this embedded system, and where we will show that what are the role of different sensing actuations or the interfacing in the embedded system, right? So this is we are discussing to create the background or platform for the courses, or basically you can say the motivations for the topics as well, right? So washing machine, all of you are aware of, most of you have you are using it in daily basis as well. So there are different type of that washing machine: manual, semi-automatic, automatic, etc. So what happened that in most of the semi-automatic or automatic washing machine, what is done that you don't need to do that much job. So hardly the human intervention is required, right? So what you do, you just it can be top loading or front loading. So you have to just rotate the knob in a particular position depending on what type of clothes you are washing. So if it is cotton or wool, so depending on that, you have to just that put the knob in that specific position. Then you have to just enter that, insert the amount of cloths, and then close it, and automatically there you have already earlier put the required that detergent powder, and automate it will as soon as you will just switch on it, automatically it will do everything by its own in case of automatic, right? So it will draw the required amount of water, then required amount of detergent powder, then how much time it needs to be rotated for washing purpose as well as for drying purpose, and finally after the that stipulated time your dry clothes will come out, right? So everything is done automatically. And how this automation is done? Without sensors, actuators, you can never imagine the automation, right? So here, if we look at the that constructions of the washing machine, that internal with respect to our that embedded system concept or embedded system aspect, then essentially it will deal with the microcontroller dedicated, then storage device like RAM, ROM, hard disk, etc., followed by that software programming, and finally we need lot of interfacing components. So for sensing purpose, we require pressure sensor, temperature sensor, proximity sensor, humidity sensors, and so on. Whereas for actuation purpose, we need motor. Additionally, we need the input button, display, etc. as well. So here are some of the input button, that motors, then the panel, front panel, then inside this you have the ROM, RAM, storage device as well. So if we try to analyze that, what will be the that use of these sensors and actuators? So someone quickly tell me why this motor is used in this washing machine. So this is very obvious. Please speak out.
So to turn the clothes like
Yes, to rotate the cloths in the particular RPM or particular speed, right? Both for washing purpose as well as for the drying purpose. Then uh, any idea that why this pressure sensor is required? Any guess? What is the relation of pressure over here?
So to
Sir,
ensure that the clothes are in the limit of like working automation.
Exactly. So the washing machine is having different ratings, like suppose 6 kg. So then the pressure sensor will that measure or sense how much quantity of clothes have been inserted over here. So if it exceeds its prescribed limit, so then it will not allow the washing process. So it can give some alarm like this. What about the temperature sensor? It will tell you that the temperature sensor is very much important, because depending on what type of clothes we want to that wash and dry, so a required amount of temperature is required. If the temperature limit exceeded, so then your clothes may burnt out. So that's why the temperature sensor is there to sense that required temperature. What is the use of proximity sensor? So you know that's lid opening, lid closing things. So the proximity sensor can detect because while rotating, the lid should not be opened, so it can be detected by the proximity sensor. Similarly, humidity sensor will tell you that whether the cloth is properly dried or not. That type of concept, right? So these are the important requirement of different sensors and actuators in this example. If we move on to the next example of ATM, so that is also another beautiful example of embedded system which we use in regular basis to meet our cash requirement, right? So if we look at the constructions of the ATM machine, so this is the typical scheme or the typical diagram. So where it include keypad, speaker, display screen, receipt printer, cash dispenser, central processing unit, then your magnetic or chip card reader, your secured crypto processor, different function key or touch screen, then vault for cash storage, as well as the overall housing. So these are the typical structure, right? And you can understand, since the ATM is dealing with the monetary transaction, so the security is very, very important, right? So in this ATM machine, what we do generally, we just insert our card, and the ATM card is detected by the machine, is read by the machine by this magnetic or chip card reader, and by reading that, then what we need to do, we need to press or enter the 4-digit pins, and after that, once you insert that pin, so then the machine will connect with the corresponding bank server, and the authentications will be checked. If the pin matches with the server or database of the bank, and if the then you have to enter your amount of cash, and if that specific amount of cash is available in your account, then the machine will automatically dispense the cash, right? So in this whole automated process, you can understand how much that sophisticated automation is required, and in order to meet this automation criteria, you require the dedicated hardwares, softwares, along with the different interfacing blocks, sensors, actuators as well, right? So you can understand that this card reader you can consider as the important sensor, and you have the that actuator, like from the vault where the cash is storage, the depending on the amount of cash, that required amount of cash will be coming out or dispensed from the machine. So there obviously some roller arrangement will be there, motor arrangement will be there, and also automatic cash counting mechanism is also there. So everything is inbuilt and very beautifully built over here. So if we look at, so these are the important components over here. Along with that, you need dedicated processor, RAM, hard disk, monitor, keyboard, etc. Along with that, different software requirement is also there, where it will deal with the that required operating system, programming, database, etc. Okay. So far, is it clear to everyone? Any doubts about the background of the embedded system, their applications, as well as the example illustration? Is it fine to everyone? Any question? Yes. Someone wants to ask?
Sir.
Yes. Please.
Sir,
Dave.
can we say that actuator is the output of the system, or is it the input?
No. So that actuator means basically some sort of triggering action. So suppose first you understand about sensor. So sensor, what it does, it senses the physical quantity which you want to measure. So suppose here the in this example, as we said, the card reader is the sensor which is basically sensing the chip or the reading the chip, whereas actuator means, so once the sensor data is read, then inside this equipment, the processor, what you have, that processor will analyze the sensor data. And based on that analysis, the processor or the microcontroller, that will generate some command. And according to that command, the actuator will be triggered to show you some physical action. So physical action means here, like the cash is getting dispensed by the roller arrangement system from this output, this that holds, what you can say, right? So it is not exactly output, but it is basically based on the microcontroller command, some physical actions will be done by the actuator. So from that sense, you can consider the output, and
Okay.
considering that, you can consider the display as the output, or the actuator as well. So if we go for formal definition, so then actuator, or basically you can suppose, if I talk about electrical actuator, then the input of the electrical actuator will be some sort of electrical quantity like current or voltage, and output can be some sort of mechanical. So mechanical means some sort of vibration, rotation, or light intensity. So those can be the output, right?
Okay, sir.
Any other question? So we will formally define about the different sensors actuator as well. So this is the just the general background we are discussing, so that you can get a feel of actual application area where we can find these sensors actuators and why the interfacing circuits are required. So coming to the another important sector of automotive, as I told, that in automotive system, like in automobile, in car, two-wheeler, four-wheeler, whatever, there are lot of embedded systems are there. You can consider some individual embedded subsystem as well as the overall embedded system also, right? So suppose in the embedded system, if we consider any individual unit, like engine control system, like speed control and braking system, like personal and car safety system. So wherever, if we look at any system of the automobile, you can find the utility of embedded system there, right? So in this engine control system, that required amount of fuel will be going into the engine, then it will be that controlled depending on the requirement, the fuel injection control, then you have this adaptive cruise control, ACC, then you have speed control braking system. So we have automatic this anti-lock braking system. So there everything is automated. Then even if you consider, suppose simple that wiper, so during rain the wiper system is there, right? So during rain, that front window of the car is getting swiped. So that thing also you can consider as a simple example of embedded system. Then you have this for accident prevention, or that reduce the that severity of accident. You have this airbag system, right? So those everywhere the embedded system is there. Then seat and pedal controls, then you have air conditioner, window, that window locking, right? So everything is automated. So everywhere you can find the utility of the embedded system, including different advanced concepts as well, right? If you look at this car, so as I said, like engine control, then airbag deployment system for accident prevention, adaptive front lighting, adaptive cruise control, automatic braking system, everywhere, active vibration control, right? Remote keyless entry, then navigation system, battery management system, active noise suppression system, driver alertness monitoring. Everywhere, every subsystem you consider, you can find the utility of embedded system. So that is the importance of embedded system. And without the sensors and actuators, embedded system cannot do anything automatically. So that's why in this courses, we are going to that learn about the details of the different sensors, actuators, their working principle, the different interfacing scheme, so that how to connect the sensor actuator with the microcontroller for an intended applications, different advanced scheme, as well as their the fabrication technology of the devices, as well as their power requirement, energy storage, security, followed by the different emerging applications. Right? So all will be dealt with in that direction. So far, is it fine to everyone? Any question? Okay. So if not, so then with this another important example of this automotive subsystem, where we can find the this utility of sensors, actuators, and we can justify the this embedded system applications. So for that point of view, we are just taking one simple example of airbag deployment system used or installed inside any car, right? And we will see how inside this small airbag deployment system, which is a beautiful example of embedded control system, what are the different type of sensors, actuators are used, and what are their important roles to develop the complete system, right? So where so I believe all of you have are aware of this airbag system, right? Where the airbag is placed or located? Quickly.
Steering, sir.
Steering, right? So suppose, as you can see, this is the steering wheel, and here you have the airbag system. So airbag system, what is its utility? So when in normal operation, the airbag is not activated, but as soon as some crash or some accident is about to happen or some collision is being detected, then and there this bag will be inflated, so that the driver who is sitting before or sitting in front of the steering wheel, he or she will not directly in contact, or directly he will not feel the high impact or the collisions with the steering in case of accident or crash, right? So as soon as the accident is being detected, the airbag will be inflated, so that the driver who is sitting over here, he or she will collide with this bag itself. So the severity of the injury will be significantly reduced or prevented as well. Fine. So obviously, in order to make this system work, what are the things required? So obviously, the first thing will come into your mind. First thing is that to detect whether the accident is going to happen or not, or the crash is happening. So to detect that, some sensor is required. So for that, we need some crash sensor, or you can consider some accelerometer sensor as well. As soon as the crash is being detected, the crash sensor or the accelerometer sensor will give some impulse or spike, and accordingly, it will try to activate the airbag system. So activate means what it will do? It will just inflate, it will try to inflate the bag. How it will be inflated? It will be, you can consider some small that processor as well, which will detect that, and accordingly that processor will give command to the inflator, which will ignite some required amount of gas to inflate this bag. So essentially, the sensors what are required over here: accelerometer sensor, wheel speed sensor, brake pressure sensor, as well as seat occupancy sensor. So these are the sensors we can consider as the important sensors present in the airbag control unit. So whenever the crash is detected, these sensors will give the corresponding output. Accordingly, that output will be analyzed by the processor, and then the processor or the controller, it will generate the command to the actuator. So what are the actuators over here? The airbag inflation device. So based on the command, the airbag will be inflated. How it will be inflated? The gas will be coming out, and it will fill this airbag, so that it will be inflated. So actuators you can consider the airbag inflation device, passenger airbag on-off indicator as the actuator. So in the event of crash, the crash sensor, for example, the accelerometer, will send a signal to the airbag control unit. That control unit will trigger the inflation device, which generates some nitrogen gas by igniting a chemical compound, and accordingly it will be inflated. So the time between crash detection and complete deployment of the airbag is approximately 0.05 seconds. You can understand the importance of the real time over here, isn't it? So within this fraction of second, this whole system needs to be activated. Otherwise, your whole purpose will be in vain. So that you can understand the importance of the term real time, what we have mentioned in the formal definition. Okay. Is the concept so far clear to everyone? Any doubt? Please feel free to ask question. Whatever question comes into your mind, please feel free. Okay. If not, so then let us stop the technical discussion over here, and we will continue from here in the next class. That is on Monday. So before that, let us quickly take the attendance, and then we will quickly discuss about the fourth slot, and then we will end our today's session. So Kirtan Manukumar Mali, are you there?
Yes, sir.
Please respond to your name. I will just call once. Okay. Then Akula, Sri Sai Kiran.
Yes, sir.
Okay. Dev Malyo.
Yes, sir.
Taritri. Kumardeep. Taritri is there. Kumardeep Bosak.
Yes, sir, present.
Kanya Ajay Dave.
Present, sir.
Hare Krishna. Agarwal.
Yes, sir.
Shashwat Datta. Avisar Das.
Yes, sir, I'm present.
Present, sir.
Avisar.
Present, sir.
Devendra Praveen.
Present, sir.
Okay. Kari Yadu Bhamsi Krishna.
Sir Devendra.
Okay.
Yes, sir.
Okay. Muhammad Hanin KP.
Present, sir.
Orpon Dev.
Present, sir.
Radhakrishnan.
Present, sir.
Kataramana.
Present, sir.
Radha Shivam.
Present, sir.
Nandakishore.
Present, sir.
Aditya. Chenna Pragada.
Present, sir.
Mamidi Hemant.
Present, sir.
Satish Mahapatra. Surya Kashyap.
Present, sir.
Patrick Ojoy.
Yes, sir. Present, sir.
Ratmesh.
Present, sir.
Evelina Pramanik.
Present, sir.
Mohan Kumar Pal.
Present, sir.
Puran Bhattacharya.
Present, sir.
Srish Mahapatra. Okay. Anyone left? Okay. Okay.